All right, so we had a little conversation about Lewis acids and bases before, and we want to make sure we understand what a Lewis acid and bases are. So here's a question to help us kind of review that. Is this an example of a Lewis acid-base reaction?
Let's see. Well, B says no because there's no hydrogens involved. But that's what we said, that a Lewis acid-base reaction didn't have to have hydrogens, right?
That's right. So it doesn't, B's not right. It's not true that it can, the answer can be false because there's no hydrogens involved. Now, there might not be enough information, I guess, but how can we tell whether this is a Lewis acid-base reaction?
Well, Lewis acid-base is just one thing grabbing onto another with other electrons, right?
That's right. Very good. So we have lone pair of electrons being reached out to form a bond here with the sulfur dioxide. Which one would be the Lewis acid?
Well, the Lewis acid is the one that accepts the share, so the oxide ion is the base.
Very good. Sulfur dioxide would be the Lewis acid in this case, and this oxide ion would be the Lewis base. Fabulous job. Okay, very good. We're not going to pay close attention to metal oxides, but we are going to talk about the auto-ionization of water. Auto-ionization of water. Okay? We already said just a little bit ago that water can dissociate into the hydrogen ion and the hydroxide ion, right? So here we have it depicted as two water molecules, one getting a proton and one releasing a proton. I prefer just the hydrogen molecule dissociating into the hydrogen ion and the hydroxide molecule, right? Hydroxide ion. Because this occurs and because it's in equilibrium, we have a K value. Do you remember what the K value is?
That tells you about the concentrations of the reactants and products at equilibrium.
Very good. It tells us about the concentrations of reactants and products at equilibrium. And the K value here is 1 times 10 to the minus 14. Okay, so the K for water ionization, auto-ionization, is 1 times 10 to the minus 14. What is the reaction, the equilibrium statement for this reaction? What is the mass action expression?
I can't remember what that means.
Remember how we said that K equals, in this scenario, the products over the reactant?
Oh, yeah, okay. So H plus times the concentration of the hydroxide ion over the concentration of water.
Now, do we include the water? This is a liquid, right?
Oh, yeah, okay. So we don't include the water.
All right. Very good. So the equilibrium expression, which equals 1 times 10 to the minus 14 when we're at equilibrium, equals the hydrogen ion concentration times the hydroxide ion concentration. And if it's just water that you have, the only thing in solution is water, then that means that these concentrations will be equal because they all came from the same molecule. So we could identify their concentrations. We could call them X times X, they're same, equal 1 times 10 to the minus 14. Therefore, X here will equal 1 times 10 to the minus 7. All right. So the hydrogen ion and the hydroxide ion are at the same concentration, both of them 1 times 10 to the minus 7, when the solution is neutral. All right. pH, now we've talked only briefly about pH in the past, but pH is a way to express the amount of hydrogen ion, H plus ion or H3O plus ion, in solution. And what it is it's an equation that, or a function that takes the negative log of the molar hydrogen ion concentration. So these concentrations, right? Concentration of hydrogen ion in molarity, the negative log of that will equal the pH. All right? So if we see that in water, the concentration of the hydrogen ion is 1 times 10 to the minus 7, if I take the negative log of this, negative log of 1 times 10 to the minus 7, negative log, oops, negative log 1 times 10 to the minus 7, that, oops, move that down a little bit, 1 times 10, negative log of 1 times 10 to the minus 7 equals 7, all right? So the pH of a solution that has 1 times 10 to the minus 7 hydrogen ion is 7. And that's why the pH of water is 7. Now, this isn't pH of tap water. This isn't pH of water that you bubbled oxygen or carbon dioxide into, or even atmospheric air, because atmospheric air has carbon dioxide, and that carbon dioxide will acidify the water. But if you just have water all by itself, the pH will be 7 because the concentration of the hydrogen ion and the concentration of the hydroxide ion will both be at 1 times 10 to the minus 7. Now, pH is the negative log of the hydrogen ion concentration. So, what bothers me about using the H3O plus ion is you don't realize what's going on here when you see the equation. pH equals negative log of H. You can see how this is that. So P of X equals negative log of X, right? So the pH function isn't a power function or something weird like that. It's just a function that allows us to compare numbers logarithmically. So numbers that change get very, very small, but make large differences. We need a different scale to express them, and so we use the pH scale. Okay? And so we can take the pOH of a solution as well. pOH equals, I shouldn't write the brackets around it, pOH equals the negative log of the hydroxide ion concentration, right? So let's try to find the pOH of a solution of water. What is the pOH of water? Well, we said that the pH of water was the negative log of the 1 times 10 to the minus 7. And what is the pOH then?
Well, you said that the hydrogen ion and the hydroxide ion were the same concentration in neutral water, right?
That's right.
So the pOH must be 7 as well?
That's right. The pH is 7 of water, and the pOH of water is 7 also. And what we see here is a relationship between pH and pOH. pH and pOH will always add together to form, or to add together to make pKW. So pKW equals negative log of KW. Now, do you remember what KW is?
No, I don't know what KW is.
KW is this value, right? Did we see it with the previous one? Here it is right here. KW is 1 times 10 to the minus 14. We wrote it down right here, right? So pKW is what?
Negative log of 10 times minus 14?
That's right. So let's put that into our calculator here. Negative log of 1 times 10 to the minus 14. 14. So, pH plus pOH equals pKW. And that's always the case. That's always the case for any aqueous solution. pH plus pOH will equal pKW. Or students generally say pH plus pOH equals 14, because pKW is 14. We have to know where that pKW comes from, right? That pKW is from the pKW is the negative log of KW. That KW, where does that come from? KW is the concentration of hydrogen ion times the concentration of hydronium ion in water. All right? All right. So, let's complete this following table let's fill in the missing data here. All right? So, again, there's a relationship between pH and pOH. and that is their sum is always 14. And there's a relationship between hydrogen ion concentration and pH. Do you know how to find the pH from the hydrogen ion concentration?
The pH is the negative log of the hydrogen ion concentration.
That's right, negative log of the hydrogen ion concentration. What about if I have the hydroxide ion concentration? Can I get the pH?
I don't think so.
Well, if I get the pOH, does that help me get the pH?
Why would that help? What is the pOH again?
The pOH is the negative log of the hydrogen ion concentration.
Okay. And the pH is the negative log of the hydrogen ion concentration.
That's right. Did I say that right? The pOH is the negative log of the hydroxide ion concentration. The pH is the negative log of the hydrogen ion concentration. And remember, the sum of the pOH and the pH is 14 always.
Okay, well then let's see. If I find the pOH, let's see, that would be 3.2 times 10 to the minus 3. So I take the negative log.
Negative log of what?
3.2 times 10 to the minus 3.
All right, so it's 2.49. So what is that 2.49?
That's the negative log. That's the pOH, right?
Okay, very good. That's the negative log of the hydroxide ion concentration. That's the pOH.
So 14 minus that should be the pH, right?
That's right. pOH plus pH equals 14. So 14 minus that value should be our pH, which is 11.5. Now, if I have the pH of 11.5, can you find out the hydrogen ion concentration?
I know how to find the pH from the hydrogen ion concentration. How do I find the hydrogen ion concentration from the pH?
That's a good question. The way you do that is, instead of doing the negative log like that, you go inverse log 10 to the negative pH, negative 11.5. And that will give me, 10 to the, let's see, 10 to the negative 11.5. There we go. What did I do? Oh, I used the wrong negative sign there. I used the wrong negative sign. I have to use this negative. I have to use the small negative sign. So there is my hydrogen ion concentration. So pH equals the negative log of the hydrogen ion concentration. If I go 10 to the negative hydrogen ion concentration, 10, find some space here, 10 to the negative pH, that will equal my hydrogen ion concentration. All right, so I got the pH of 11.5, and 10 to the negative 11.5, negative pH, is 3.16 times 10 to the minus 12. Okay, very good. Does that make sense?
I think so. Let's try that again.
All right, I'd like everybody to take pause and try to fill in the rest of this chart and see how well you do. You have to take this time to exercise. If you don't, then you'll be in trouble. Okay, ready to go?
Yeah, here we go.
All right, if I have the hydrogen ion concentration, then it should be easy to get the pH, right?
Yeah, just negative log of 2.3 times 10 to the minus 5.
Very good. Negative log of 2.3 times, negative log of 2.3 times 10 to the minus 5. All right, so 4.6 is my pH. Now, how do I find the hydroxide ion concentration from that?
Well, you got the pH. 14 minus that would be the pOH.
That's right. So 14 minus that would be the pOH. And now what?
Can you do 10 to the negative that value to give you the hydroxide ion concentration?
Yes. So 10 to the negative that value there, and that'll give me the hydroxide ion concentration. So 4.3 times 10 to the minus 10, that's the hydroxide ion concentration. pH, is 4.63. Okay, hydroxide ion concentration. How are we going to get the pH?
Get the pOH first.
So negative log 1.5 times 10 to the minus 2. There's the pOH. How do I get the pH?
14 minus that.
14 minus that value. pOH 12.17. How do I get the hydrogen ion concentration?
10 to the minus that.
10 to the, whoops, to the minus that, 12.1. All right, very good. Last one.
Okay, negative log of the hydrogen ion concentration.
Very good. Negative log of 2.55 times 10 to the minus 6.
That should be the pH.
All right.
And then the the hydroxide ion concentration, 14 minus that. That should give you the pOH. And then 10 to the minus that.
All right. 3.9 times 10 to the minus 9, and pH is 5.6. Very good. Important to learn our way around the pH scale. Okay, good place to stop.